This is a video tutorial for EMS160. My name is Ryan Philhauer. I'm in EMS260 with Professor Gentry. And today we're going to be talking about how to determine equilibrium concentration from a Gibbs free energy versus composition plot. In this example, we have a binary system that has two components. First component is component A. Second component is component B. And these components can be an element like hydrogen or iron or nickel, or they can even be compounds like silicon dioxide or methanol. And this system is at a constant temperature, T1. And there are three different phases that exist or that could exist for this system at this temperature. The first phase is the alpha phase. Second phase is the liquid phase. Third phase is the beta phase. And the curves plotted are the molar Gibbs free energy curves. And the units for that is joules per mole. On the x-axis is the composition of B that's plotted. So all the way to the left is 0% B component, 100% A component. All the way to the right is 100% B component, 0% A component. So what this method is going to show you is the composition of B for a specific component at a specific temperature. And the technique is called the common tangents method. Easiest way to do that is to use a straight edge, and you follow a curve around. I'm just picking the alpha curve arbitrarily. But you follow the curve around until it hits another curve. And in this example, it's going to hit the beta curve right there. And we're just going to connect that with a line right there. And this is showing you a couple things. First thing it shows you is the stable phases that exist. So the first stable phase is the alpha phase along this line right here. The second stable phase is the beta phase, which is right here. And then in between the two is this area right here, which is a mixed phase of alpha plus beta. The second thing this is showing is the compositions of B in those two phases at this temperature. So if we just drop a line down here, it intersects at that point right there. Similarly, if you drop a line down here, it intersects at this point right here. And we'll call this point number 1 and this point number 2. I'm talking about these points right here. So point number 1 is showing you that the composition, X, of component B in the alpha phase at this temperature is 0.25, or 25% alpha phase. Similarly, point number 2 is showing you that the composition of B in the beta phase is equal to 0.75, or 75%. For more information on this, you can look at the textbooks. Chapter 10 in de Hoff and Gaskell will give you a little bit more information. Thanks.